All right, part 2, Unit 1, test review. Start with number 16.5. The reason I put that on there was because I noticed we didn't have a negative common difference. I just wanted to put a little emphasis on that. So, from here to here, the difference would be -5, and that is consistent from here to here and here to here. And so we say, yes, it is arithmetic sequence. Difference is -5 because it's going down. All right, here's your buddies, the formulas. And we're going to tackle these in questions 17 through 19. Start out with somewhat simple question. What is the sum of the following arithmetic sequence? So student number 1 on a problem this easy could just go ahead and add them up. 2 plus 6 is 8, 8 plus 10 is 18, 18 plus 14 is 32, 32 plus 18 is 50, 50 plus 22 is 72. And there's really nothing I can do to stop you. But the intention is that you understand this formula so that you can apply that formula to some of these tougher ones. So if it's saying find the sum, I would connect this letter to that letter, and this is representing of what term? So we take a look at this and we say 1, 2, 3, 4, 5, 6. There are 6 terms, so that's a 6. Whoops, sorry, I should have put a 6 in there. That's telling us just let n equal 6. My first item in my sequence is a 2. That's what a sub 1 stands for. This stands for my final element in my sequence, which is 22. All over 2. Now this is a basic math problem 101. So this is 6 times 24 all over 2. And I'm just going to go like this. 2 goes into 6 3 times. 3 times 24, 72. So, good little review on how to use this formula and what these pieces are. So, if we get a little confused down on these problems, we can go back to this. Now, this one comes at you a little different. It says, find the sum. It's like, okay, I'm going to use this formula if I have all the pieces of an arithmetic series with given numbers of terms a sub 1 and a sub n. They're just making a problem like this a little less upfront. They don't just give you a list, they give you clues about the list. So we know there are 10 terms. That's just telling you let n equal 10. Just like there was 1, 2, 3, 4, 5, 6 terms, so this is a 6. This has 10 terms, so n is 10. So I'm going to start filling things in and see where it takes us. Actually, this is my 10th term, so I can fill that in. It's just part of the formula that doesn't really help me. It's the 10th term, other than telling me n is 10. And then tells us, just spoon feeds us. The first term is a 4. And the final term is a 31. So yeah, we have enough information to get her done. But you can see how important this formula is when they give us the problem like this. And so now we just do some number crunching. 10 times 35 all over 2. 2 goes into 10 5 times. 5 times 30 is 150. Plus 25 is 175. Okay, I got a separate piece of paper because I didn't leave you much room to work on this one, but the members of a school's color guard begin their performances in a pyramid formation. The first row has 1 member, the third row has 5 members. As you can see, there's no obvious sequence. Like, they don't say the first row has 2, the second row has 6, the third row has 10. There's nothing arithmetically obvious. The sequence isn't obvious. They're hiding it. So they're kind of helping you, even though it sounds complex, by saying, what is the explicit definition for the sequence? So we can't use this formula. They're not even asking us for all the people in the color guard, so don't be tempted to use this. They're talking about this. So what is the explicit definition for the sequence? Again, notice up here, we're like, hey, there's a difference of 7, a difference of 7, a difference of 7 from row 1 to row 2 to row 3 to row 4. We don't have that because it jumps from the first row to the third row. That's what's saying, all right, this is one of those tricky ones where I got to find D somehow before I can even use this formula, because that stands for common difference. And here's how you're going to go about that. You're going to find that by saying, what is the explicit definition for this sequence? So the formula they're directing our attention to is this one. Now, what are we trying to find? D. How do we go about that? Well, we're supposed to know n, a sub 1, and a sub n. I know that sounds overwhelming, but look at, I'm going to go for the low-hanging fruit. This is the number of our first term in our sequence. The first row has one member. We're trying to find the common difference. We'll get to that. And notice it says the third row, so they're saying, all right, a sub n is now the third row. The value of that element in that sequence is 5. So we're going to replace this with a 5. And we also know that there are clues all over the place where it's what is n? Well, we replaced it with a 3. So that'd be 3 minus 1. Now I've got a basic algebra problem. 5 equals 1 plus 3 minus 1 is 2. 2d, subtract 1, subtract 1. 4 equals 2d, divide by 2, divide by 2. We get d is 2. Now they're asking, what is the explicit definition? Well, once you find d, you can now replace that right here, and you have a sub n equals a sub 1 plus 2 times n minus 1. And what this allows us to do is find any number of people or members in any particular row. So we created our own little formula essentially. Now if we just take a glance at number 19b, how many members are in the 9th row? So what they're looking for is this value, which we don't know. We'll put a 9 in there. That's telling us let n equal 9. That's essentially what you're doing. So we know there's one member in the front row, and we're concerned about the 9th row. So we do the math. 1 plus 2 times 8, which is 16, and that would be a total of 17. So the 9th row would have 17 members in it. All right, number 19C, trying to squeeze this in for us. It says if there are a total of 9 rows, so notice in letter problem B, we're talking about the 9th row, which is a little boost for this problem. If there are a total of 9 rows, how many total members? That's why we're going to use this formula, the total sum of the entire situation. Total members of the color guard. So we know there are 9 rows. So that's going to tell us to let this be 9. And our first row has 1 in it. Our last row, that's what this represents. Our 9th row has 17 in it. Now we're going to divide that by 2. Careful with your math. 9 times 18 all over 2. I'm going to go ahead and divide 18 by 2. That's 9. 9 times 9, 81 members of the color guard. All right, to Desmos.com we go. Number 20 says use a graph to solve absolute value of x plus 8 equals the absolute value of x minus 2. So that looks pretty crazy. So what we're going to do is we're going to set them both equal to y, just like we did in our homework and our lessons, and then just look at where they intersect. So Here we go. The absolute value of x minus 8, and there it is right there, equals the absolute value of x minus 2. And we just take our cursor, hang it right over there, 5, 3. So 5, 3 would do it. That's it, guys. All right, getting to the end of this review. Solve the systems of equations. Now, you're supposed to be doing this by using algebra. I notice I got a 6y and a negative 6y. I'm just going to go ahead and add these together because they eliminate. So 2x minus 2x plus a negative 3x is negative x. These cancel, and I get 19. Multiply both sides by negative 1. X equals negative 19. Still got to find y, so I'll pick the top one. 2x plus 6y equals 10. Put negative 19 in here, do the math. Negative 38 plus 6y equals 10. I'm going to add 38 to both sides. I'm going to use my space up here. 6x equals 48. Divide by 6, divide by 6. X is 8. So for this one, the numbers worked out nice, which they don't always. Whoops, I started. Ooh, there's a mistake. Got ahead of myself. I slapped a y, an x in there. All right, so that's not true. My x would be negative 19. My y would be 8. All right. Letter B, what I did on purpose was set you up for either substitution. You could put 2y minus 5 right into that x. But instead of doing that, I'm just going to rearrange this one and give you another example of elimination. And all I'm doing is lining up my x's and lining up my y's. And now what should I eliminate, my y's or my x's? I'm just going to take a look at this one, multiply by negative 3, because I'm going to attack that 3x. I'm creating a negative 3x plus 6y equals 15. I'm going to add these two together. 3x and negative 3x is 0. Negative y and 6y is 5y. 5 and 15 is 20. Divide by 5, I get y is 4. I'm going to plug it back into this one. X minus 2y equals negative 5. So that's x minus 2 times 4 equals negative 5. This is negative 8, so I'm going to add 8. And I get x is 3. So my final answer for this one would be 3, 4. Okay, letter C, 21C, ran out of, this is going to require a lot of space, so I got this little copy here. Remember, when there's 3 variables we're trying to find, we're not done until we find x, y, and z. So the trick here is to kind of scan it and ask yourself, if I was to add 1 to 2, 1 to 3, or 2 to 3, could I get things to cancel? And what's jumping out at me, just scanning for opposites, are right here. So I'm going to start by adding equation number 1 to equation number 3 and create a fourth equation. X plus x is 2x. Y plus negative 4y is negative 3y. Z plus negative z, they cancel. That's what I want. Equals 9 plus 2 is 11. Now notice I've already manipulated 1 and 3. So I'm not going to do that again. I'm going to either use 1 and 2, or I'm going to use 2 and 3. So for this one, I'm going to choose to use equations 2 and 3, because I can see that if I multiplied this one, I'm focusing on that z, by a positive 2, it would result in a negative 2, and that